Section 5.5, triple integrals in cylindrical and spherical coordinates. Recall that cylindrical coordinates are in the variables r, theta, and z. R and theta you can recall from polar coordinates, and z is the same z coordinate as in rectangular x, y's, and z's. In this video, we're going to look at cylindrical. In a later video, we'll look at spherical, which has variables rho, theta, and phi. Here in this picture, we have a cylindrical box. So we have hard bounds on r's, thetas, and z's. If we see the box has 3 dimensions, a projection of the box into the xy plane or the polar plane produces a polar rectangle. That we have hard bounds on r and we have hard bounds on theta. You can also recall from polar integrals that the area differential picks up an additional factor of the variable r when computing out small polar area measurements. So to take an area measurement measured in polar coordinates and multiply that by a height variable will give you a volume measurement. So for this cylindrical box, we can find volume measurements by looking at these computations. That then will allow us to define a triple integral expressed out in cylindrical coordinates by taking a limit of a triple sum where we're varying r's, thetas, and z's. You'll note that when we actually integrate, the z will be done typically first, and then r, and then theta. All right, with that definition then, we go back and we rely again on our trusty Fubini to say that the formal setup of the triple integral may be computed as an iterated integral, where we're iterating in the variables, cylindrical variables, z, r's, and thetas. So again, the book has a quirk in it that the more standard order is going to be z's, r's, and then thetas. So if we take a look at example 543, we're provided with a triple integral to evaluate. And then we have a cylindrical box, and that means that we're going to get hard bounds on the 3 cylindrical variables, r, theta, and z. So to set up the triple, the only thing that you really need to remember is that the volume differential is going to be comprised of dz and then the area differential in polar coordinates, which has the extra factor of r. Nice.